Deep neural networks operate by iteratively minimizing error rates, resulting in a mathematical black box challenging the foundations of tort liability and administrative law. Welcome to Wandt courseware, an AI-narrated technology video series unpacking the latest lectures and thoughts from Professor Adam Scott Wandt. This series originates from the John Jay College of Criminal Justice in New York City. We are currently attempting to regulate systems that dynamically learn and operate opaquely, using legal frameworks designed for predictable, static human actions. Approaching AI as the culmination of decades of computer science, philosophy, and legal theory allows us to move past technological hype and identify what these systems can actually do. Effective AI governance must be a proactive alignment of multiple disciplines, rather than a simple reaction to sudden technological failures. This unified governance architecture rests on three pillars: computer science, philosophy, and law and policy. This course maps the operational mechanics of artificial intelligence directly against the hard boundaries of legal enforceability. A fragmented approach is a liability. Technical analysis without legal constraints is dangerous, and legal theory without technical grounding is unenforceable. Public administrators must maintain a unified mental model across all three disciplines to design human-centric values into technological life cycles. We begin with the first pillar, computer science, and the shift in how machines process complex tasks. This represents symbolic AI. These are expert systems that rely on explicit, human-coded logic and rigid rules to reach a conclusion. Symbolic AI fails when it is required to scale across highly complex, unstructured environments where every possible variable cannot be manually coded. This led to the development of Sub-Symbolic AI, or machine learning, marking a transition from explicit coding to data-driven learning. In this paradigm, the machine does not follow a set of human rules. Instead, the model iteratively adjusts its own internal mathematical parameters during training. These parameter adjustments serve to minimize error rates, enabling pattern recognition at a scale that human-authored software cannot replicate. The trade-off for this capacity is a loss of the predictability inherent in traditional, hard-coded software. The specific mechanism neural networks use to adjust these internal weights is called backpropagation. Continuous backpropagation creates an increasingly dense, interconnected web of statistical relationships within the network. As these systems evolve into general-purpose foundation models, this web becomes mathematically impenetrable to human review, creating the black box problem. This mathematical opacity complicates the auditing and validation protocols required for public sector compliance. Public policies that demand absolute algorithmic transparency are very often unrealistic given the mathematical complexity of deep learning. The black box is a fundamental technical reality. Administrative governance must proactively work around this opacity rather than treating it as a fixable design flaw. Our second pillar, philosophy, establishes hard boundaries on the nature of machine intelligence. We must distinguish between weak AI, systems designed for specific statistical prediction, and strong AI, which implies genuine human-like cognition. Philosopher John Searle's Chinese room argument highlights this distinction, illustrating the gap between processing symbols and actually understanding them. Modern generative models produce human-like language by calculating the next logical word, yet they possess no semantic awareness or intentionality. Policymakers must avoid the anthropomorphism trap, the reflex of attributing human characteristics like empathy or objective judgment to an algorithm. Treating AI as an independent thinker leads directly to misplaced trust and regulatory capture. Public administrators must regulate AI as unfeeling prediction tools, ensuring human agency is preserved in high-stakes decisions. Under the third pillar, law, we examine the friction that occurs when these opaque mathematical tools are deployed into human society. The autonomy and opacity of deep learning disrupt traditional legal doctrines, such as tort liability, which rely on the premise of predictable human agency. Administrative law struggles to assign responsibility when an autonomous system makes an unexplainable error. This creates three critical legal vulnerabilities. The first is justice inequity, specifically the propagation of systemic bias through scaled data. The second is safety and certification regarding accidental harms caused by algorithmic hallucinations. The third is privacy, given the mass data ingestion required to train these models. Existing regulatory models are designed to react to failures after they occur, rather than intercepting them during a system's development. Administrators must forge new, proactive mechanisms to bridge the gap between abstract ethics and enforceable mandates. A unified governance roadmap prevents the overlapping jurisdictions and loopholes that result from fragmented agency-by-agency regulation. This necessitates a national strategy, coordinated by interagency bodies that possess deep native technical expertise. We are seeing an acceleration of AI policy globally, with the OECD AI Principles and the EU AI Act serving as models for proactive framework design. These international frameworks are united by themes of transparency, algorithmic accountability, and the mitigation of systemic bias. Without specialized administrative bodies, public institutions are vulnerable to regulatory capture by the private tech industry. Successful policy design translates global guidelines into actionable compliance protocols for local jurisdictions. The shift towards sub-symbolic AI in civic infrastructure carries significant practical weight for public sector leaders. Automated systems are already being integrated into high-stakes services like housing allocations, education access, and law enforcement. This environment requires administrators to build the institutional capacity for robust, continuous evaluation mechanisms. This evaluation must monitor the system throughout its dynamic, learning-based lifecycle rather than serving as a one-time check. By understanding the technical reality of the black box, administrators can move past the hype and demand rigorous accountability. Like, follow, and subscribe for more deep dives into emerging technology, digital investigations, and the ideas shaping our future. Remember, stay curious and want knowledge.